This is a kind of complicated procedure, but in your case, we make it, we make it easy. We talk about area of a different region. Remember, I try to motivate this idea, but didn't use any technical points. So if you want to find the area of the region, if the area is known, you see you can use some formulas to find it. But we just get a curvilinear one like a circle, it's calculus. If it's going to be curvilinear, we can estimate it. So I show you how we can estimate to get a region, and eventually we get, okay, if you have a continuous function, and this is going to be the area under the curve. If you want to find this area, there is no formula for this one because it's not a kind of geometric region that you know it. So what we can do, we can cover it. We can partition it, okay? We can cover it by some rectangle and then find the area of this rectangle and estimate it. If you put these together, it's going to be the notion of the, you see this, when you want to approximate it, we are going to eventually approximate it by a new kind of integral. That integral is going to be called the definite integral or a Riemann integral because of the guy who created this integral. So this integral is going to be a number, because it's going to be the area. The previous one was a function. So that was enough motivation for this course to introduce the new integral that we are going to call it the definite integral. So the definite integral with this notation means a function is given to you. This is y equal to the f of x. And there is going to be an area. You see, there's going to be a function. And this is going to be the area under the curve, we call it, under the graph of this function. So if you want to find this area, we are going to denote this area by this notation. And this is called the definite integral or Riemann integral. There are different ways to define the integral, so it depends on what type you are going to use. You're going to have a name for it. This is the most popular one, Riemann integral. There is another one, we call it Lebesgue integrals. So we are going to take it from here. And as I give you one example just to motivate it for you, then we are going to find a method that we be able to find these integrals, okay, from the area. So give you the easiest possible formula first, okay? So look at this example. At this example, we wanted to evaluate this new integral. Evaluate. Okay, the integral, this new one that we talk about it. Suppose you want to evaluate something like, let's say 0 to 3. Okay, 0 to 3 and something like a 2x dx. So this notation that we talk about it, this means you have to find the area under this curve. So officially, so far, this is how we can find it. We have to draw the region. Okay, so your function is f of x equal to the 2x, or you can call it y equal to the 2x. Okay, and your x is going to be only between 0 and 3. So this is going to be your x between 0 and 3. It's just a straight line. So if you want to graph it, you need only 2 points. So we can evaluate it at these points that we have. This is going to be the x, and this is going to be y equal to the 2x. The point that you have x is equal to the 0. If you put the 0 here, 2 times 0 would be 0. Okay, and x equal to 3. X equal to the 3, if you substitute the 3, so 2 times 3 would be 6. So let's see what type of region we are going to have. So look at this one. So in this case, the point 0, 0, this is going to be the origin. Okay, this is going to be the 0, 0, then 3 and 6. So it's going to be 1, 2, 3, and 6. 1, 2, 3, 4, 5, 6. Okay, so if you connect them together, so this is going to be 6, 3, and 6. So let's see what type of shape are going to have. So this is going to be the graph. Okay, it's going to be a straight line. Okay, this is going to be the straight line. So this is 0. This is 3. So the area that you are going to be questioning, you see, this area is the one that you are going to be interested in. Okay, so far this integral from 0 to 3 2x dx means finding the area of this region. As you can see, this region is going to be what? Is a triangular region. It's going to be a triangular region and is a right triangle. So we can find the area of this triangle. As we talk about it, the area of the triangle, your base is going to be this one. You see, this is going to be the base. So for this triangle, the base is equal to 3. Okay, then you need the height. Since it's a right triangle, this is going to be the height. Okay, this is going to be the B, and this is going to be the, okay, this is going to be the height. This is going to be H. So what is going to be H? 0 to 6. So the H is equal to the 6. Okay, so the area in question is going to be 1/2 of the B times H. And if you substitute, it's going to be 1/2 of the B is 3, H is 6. So 3 times 6 would be 18. 18 over 2 would be 9. So the area in question is going to be equal to the 9. So the integral from 0 to 3, the 3x dx is equal to the 9. It's the unit of the area, whatever unit you have, is going to be unit squared. Okay, any question? So this was easy. Okay, this was easy because the area of is going to be just a triangle. But if you give me y equal to the x squared, if you give me y equal to the x squared, I'm not going to have a triangle. I may have something else. So I won't be able to find it to get this, this number of the observations. So what is going to be the method that we're going to have? Now, look at this one. Any questions so far? So this integral means the area under the curve. So officially, if you want to find it, you have to get the area and then find the area, which is not easy. But let's see how we can get this 9 from the concept of the integral. Okay, look at this one. Note that. Let's find this integral. You see, forget about 0 to 3. How we're going to do the antiderivative that we did before. What is the integral of the 3x? Any suggestion? What's the integral of 3x? Integral of 3x. Let's use the power rule. What's going to be the result? Any suggestion? Three is a number. We keep it, remember? X power rule. You add 1 to the power, remember? 1 up. Action of integration. Action of integration is going to be, that give you x squared divided by 2, remember? That's how we take the integral. 3 is a number, x dx, the power rule. Action of integration. You add 1 unit and you divide. We usually add the c to it. So let's forget about the c. So if you simplify it, so you cannot simplify it. So this would be what? This would be 3/2 of the x squared. If you just go with the ordinary integral. Now, let's see how we can get the 9 here. So in order to get the 9 here, you see you have from 0 to 3. So what we are going to do is, I'm going to evaluate this one. I'm going to evaluate it when x is equal to 3 and when x is equal to 0. Let's use this notation means I am going to evaluate this one. So this is going to be equal to the what? This means this is a 3/2, and that would be 3 squared. Okay, I subtract it, and that's a 3/2. I'll put the 0 here. 3 squared would be, okay, 3 squared would be 9. Did I miss anything here? That is going to be, that was a 3x squared, x squared over 2. Okay, I should have missed something somewhere. What is that number that was a 3x squared over 2?
Isn't it 2x dx?
Which one?
Isn't the original problem 2x dx?
Oh, excellent, very good one. Original one was so original one was what? Yes, you are right. Thank you. That's a 2x. Okay, thank you. Because otherwise, I cannot give you on that motivation over here. So let's be something. Excellent, thank you. That's a 2. And this is going to be 2. Okay, this would be 2. Okay, so what we have, this is going to be 2 over 2. So that this can be canceled out. So 3 squared would be 9. 3 squared would be 9, and this would be 0. So it's going to be 9 minus 0, which is equal to 9. So we get we get the same answer. So that would suggest something to you, that if you want to do it in general, okay, this notion that we did, this new integral is just the area. The action that I did over here is just antiderivative that we did it before. What we are going to do, we are going to write this one for you as a theorem. This is such an important result in calculus that we are going to call it the fundamental theorem of calculus. This means this is the best, this is the crunch. So what is the fundamental theorem of calculus? This means if you want to find the definite integral from 0 to 3, a to b, a function, integrate it first, then evaluate it. This result gives you the integral. And then you can find all the area, not only the area, or anything else you like. In the history of calculus, there were two different directions. One direction they worked with the area and they just estimated all the time. And one direction was the antiderivative that we did before. But it was Cauchy, Agustin Cauchy, that connect these together. And the result is fundamental theorem of calculus. I'm going to write it down for you. That was just a motivation so that you believe it when I write it down for you. Okay, and that makes things so easy for you because you don't need to go anywhere else. You already got all the techniques of the integration. You just do this substitution and then you're done. So that would be the best part of the course, or the best theorem. What is the fundamental theorem of calculus? Some people, they call it fundamental theorem of integral, but no, it's a fundamental theorem of calculus. Okay, so what is this theorem? It's connect two types of integration that we talk about: antiderivative and the Riemann integral together. So what's going to be the condition? The condition is this one: if f is a continuous function, on the closed interval of a comma b. Okay, that's going to be one. And f uppercase 1 is going to be an derivative, antiderivative of f on the closed interval of a and b. You know that antiderivative means such that f prime of x is equal to the f of x for all x inside a and b. That's the definition of antiderivative that we did it before. Okay, so this is one type of integrals. Now what's going to be the conclusion? The conclusion is then that lower f that we started, f is integrable. We say Riemann integrable or Riemann integrable. F is Riemann or just integrable. Means you can find the integral. Integrable and Riemann integrable on the closed interval of a and b, and that's a nice part. If you want to find this integral from a to b, f of x dx, those area problem, what are you going to do? You are going to find the antiderivative first. You integrate it as you did it before, f of x, then you evaluate it from a to b. This means it's equal to f of b minus f of a. So this means you just use the formula that we did before, okay, the power rule, the substitution method, whatever it is, okay? So you are going to use all the previous method that we talked about that can be applied, okay, using those type of method, but at the end, you evaluate it. When you substitute these numbers, the result is going to be just a number. It's not going to be an integral. Okay, so in one side is the new integral, definite integral, Riemann integral, area problem. On the other side is antiderivative. So you have the formulas, and this is how you connect these two together. That's why we call it fundamental theorem of calculus, because it's connected these two together. Okay, so that will help us, to find any integral of this format. So from now on, if you see the integral with these numbers, okay, boundaries a to b, you know that you have to use the previous formula, but at the end, you have to substitute. If there is no number, that is going to be just antiderivative, and we did it as before. Okay, any question? Now we have to do it. There are two types. One ordinary integral, one the one that you have to use with the substitution method. Okay, and we give you both of them. One question, two parts for your next quiz 4, and of course on the final. Any question? You see, each discipline, each subject in mathematics would have a fundamental theorem. For example, if you do arithmetic, there is a fundamental theorem of arithmetic. What is the most important result in arithmetic when you work with the numbers? That result is the theorem that will tell you that any number is a product of prime numbers. You see 6 is 2 times 3. 15 is going to be 3 times 5. So that's called fundamental theorem, because if you don't have those prime factorization, you can't do anything with the numbers. You cannot find common denominator. You cannot simplify. So that's the one for the arithmetic. In algebra, what is the most important result in algebra? Fundamental theorem of algebra. In algebra, you solve equations. Okay, you solve equation. If the equation, the degree of the equation is 1, you get 1 solution. If the degree is 2, you get 2 solutions. Fundamental theorem of algebra is that if you have an equation with n degree, that equation would have n solutions all the time. The solution may be complex numbers. So that would refer to it as a fundamental theorem of algebra. And this is for the calculus. Okay, so if you see this type of expressions, this is what it's all about. Now your job, 2 nice problems. of them. Example, we want to evaluate each integral. Evaluate each integral. So automatically you will see that the integral is a definite one. Sometimes you say evaluate the definite integral, or sometimes you say evaluate the integral. You find out yourself. So that's a type 1. Type 1 is integral from -1 to 2. As soon as you see the numbers, you say, oh, it's a definite integral. 4x cubed. 4x cubed minus 2x plus 2 dx. See, that's type 1. In this type, no substitution method is needed, you see, because you have only powers of x. So how are we going to do it? There you are. Ignore the -1 and 2 to start with. Find this integral. Use the power rules. When you go in, you find the function, then evaluate it. Add 2 and -1. And then the result will be a number, and you're done. Okay, are you ready? Solution. Easy integral to evaluate. So what is integral from -1 to 2? 4x cubed minus 2x plus 2 is equal to, integrate as before. 4 is a number, keep it. For x, power rule, move up. X to the 4th over 4, done. Next, minus 2 is a number, move up. X squared over 2. Positive 2, you know that is 2x to the 0, so it's going to be 2x. No constancy, because you evaluate from negative. Even if you add the constancy, it would be cancelled out, but we don't write it down. Okay, so now you have to evaluate it from -1 to 2. This is the notation that we're going to use. From -1 to 2. Simplify first, then start substituting. The simplification would be these 2 would cancel out, and these 2 would cancel out. So you end up with what? You end up with x to the 4th. X to the 4th minus x squared. X to the 4th minus x squared plus 2x. Plus 2x to be evaluated from what? Evaluated from -1 to 2. -1 to 2, now substitute. You substitute, you put x equal to 2 first. Equal to, carefully substitute. Use parentheses when you substitute the numbers. 2 to the 4th minus 2 squared plus 2 times 2. Okay, 2 to the 4th, 2 squared plus 2 times 2 minus, open up the parentheses or a bracket, just do the rest. You must open up the parentheses because of this negative sign. Okay, -1, substitute. -1 to the 4th. Okay, minus -1 squared plus 2 times a -1. That's going to be the second part. Okay, you replace the x by 2 minus, replace the x by -1. Now go ahead, again, carefully evaluate it. 2 to the 4th would be 16. Okay, 2 squared would be 4 minus 4. 2 times 2 would be 4. Okay, a minus. Inside the parentheses, -1 to the 4th would be 1. -1 squared would be +1. There is a negative here, -1. Okay, and 2 times -1 would be a -2. Go ahead. This 4 and 4 cancel out, that gives us 16 minus. Inside, 1 and -1 would cancel out, that gives -2. Now apply the negative sign. 16 plus 2 equal to 18. That's it. So the integral from -1 to 2, 4x cubed minus 2x plus 2 okay, plus 2 dx is equal to the 18. And you're done. So that's the way you evaluate the so-called definite integral. It depends what you have for this quantity in future. It can be area under the curve, or it can be anything else. If you're going to be in statistics, this is going to be a probability. If you're going to be in chemistry, it's going to be, okay, this is going to be something else. So we evaluate it, and then depends on the application that we're going to have. Any question? So, and that is going to be the type 1. The type 1, there is no substitution. Okay, you don't need any substitution because they are all powers of the x. So you integrate as you did before, just using the power rule. Then you are going to evaluate your integral from -1 to 2. You put x equal to 2 first, minus, you put x equal to the -1, and then you find the result. Just make sure that when you do the mathematics, okay, those operations, and make sure that you know you arrive at the correct answer. Okay, any question? No, that would be type 1. Type 2, the type 2 you want to integrate, but the function in question, okay, the function in question, let me just give you one more, you know, with the radical fractions, this is the type 1 to get to know them. Then I'll give you the substitution method. So it can comes with anything, okay, all the function that we did. So let's have another one. Let's try this one. How about integral from 1 to 4? Okay, integral from 1 to 4 of what? 6 radical x. 6 radical x minus 5, okay, 5 over x squared plus 1 dx. That's it. Again, it's 1 to 4, so it's a definite integral. Okay, so what we're going to do, we are going to integrate it first, and then we evaluate it from 1 to 4. To integrate it, there is a radical here. You know that we change the radical. So we change this one into the x to the 1/2. There's a fraction here. There is a fraction, there is a power here. So you move it up. Remember, if this x squared was x, you're not going to move it up. We use the natural log. Okay, so we have to rewrite it and then do the job. So solution. So we start by rewriting the integral. 1 to 4. 6 radical x would be 6x to the 1/2 minus 5x to the -2 plus 1 plus 1 dx. Okay, you have to rewrite it to be able to do it. Now continue, integrate. 6 is a number, so it's going to be 6. Move up, x to the, it's a 1/2 plus 1. 1/2 plus 1 would be 3/2 over the 3/2. Okay, that's the first one. Minus 5, move the power up, x to the, it's a -2. -2 plus 1 would be -1, divided by a -1. 1 would be 1x, x. It's therefore the integral from 1 to 4. So we are going to evaluate it from 1 to 4. Any question? So, you know, the extra job was just to rewrite it. Okay, to rewrite it first, and then you simplify it first, and then start substituting. The simplification is you divide by a fraction here, you know that you flip it. So it's going to be equal to the 6 times by, that's a 3/2 would be 2/3. Okay, 2/3. That's a 2/3, x to the, okay, x to the 3/2. That's a 1. Now this one over here, negative, positive. Remember, no negative power. So it's going to be, you put the 5 on the top. 5 on the top, x to the -1, you bring it down, you call it x. Okay, and plus x, and plus x. Plus x to be evaluated from 1 to 4. Okay, go on. This would be simplified because 6 and the 3, you can simplify it. So that give you 2. 2 times 2, 4. So that give you 4. 4 x to the 3 halves. It's 4 to x to the 3 half, and the leftover is going to be just 5 over x plus x. Plus x, this is going to be evaluated from what? Evaluated from 1 to 4. Any question? We just simplify. Now we have to substitute. Okay, you got to be careful for this part. We substitute first x equal to 4 minus x equal to 1. Okay, so it's going to be equal to, replace the x by 4. 4 times. 4 times what? 4 to the 3 halves. That's first part plus 5 over x, but x is 4. Okay, plus x is 4. So that means we put x equal to 4 minus. So you open up the parentheses and you replace x by 1. If you replace x by 1, that give you just 4. That give you only 5 because it's 5 over 1. Okay, if you like, I'll write it down. And this is going to be 1 again. Okay, for the first part, we replace the x by 4. And for the second part, we replace the x by 1. Okay, go on, simplify it. Okay, the challenging one is 4 to the 3 half. How are we going to find the 4 to the 3 half? There are different ways to find it. You can use your calculator if you like. But you see, this is how we think about it. 4 to the 3 half. There are 2 ways to do it. You can raise 4 to the 1 half first, then cube it. Or you can cube it and then take the square root. The easiest part is you think about the 4 to the 1 half first, then cube it. 4 to the 1 half would be radical 4. 4 to the 1 half, you see this is going to be a radical 4. And radical 4 would be 2. So that gives you 2 cubed. And the 2 cubed is 8. Okay, so this is the way you are going to, when it's going to be radical case, this is going to be always the case. Okay, it's the 4 to the 3 half. We write it down as 4 to the 1 half, then cubed. 4 to the 1 half would be radical 4. Radical 4 would be 2. 2 cubed would be 8. Okay, so we got 8 here. So what's going to be next? 8. This is just a 5 quarter plus 4. I simplify the inside. You have the 4 and the 5 would be 9. 9 and the 1 would be 10. So that gives minus 10. Okay, simplify it further. I have 8 and 4 would be 12. 12 minus 10 would be 2.
Aren't you forgetting that the 8 is times the 4?
Yes, you are right. Yeah, yeah. Okay, thanks. So it's going to be 4 times 8, yes. So 4 to the 3 half, yes. 4 to the 3 half was 8. That's 8. We have the 4 here. Yes, you are right. 4 times 8. I get the 5 quarters. So I go one more step. 4 times 8 would be 32. Okay, that gives you 32, and this is going to be 5 quarters. Now 4 minus 10 would be -6. Okay, the 32 minus 6 would be what? That would be 26. Okay, so that gives you 26 plus 5 quarters. Now a little bit of common denominator one. The common denominator would be 4. So 4 times 26 would be what? 4 times 6, 24, 10. 104 plus 5, which is going to be 109. 109 over 4. So the integral 1 to 4, the original one. 6 radical x minus 5 over x squared plus 1 dx is what? Is equal to the 109 over 4. And we are done. See, when it's a couple of radicals, it takes a little bit more time, but we got to be prepared for it. You get all sorts of, everything you did before, you can bring it here. Therefore, those integration part. Okay, any question? So that's, kind of a little bit technical one that we're going to have. Now, in these two examples that I gave you, I didn't need to use substitution method because these are all just powers of x. But you know that many integrals that we did find were involved with the substitution method. So you can bring those here again. Okay. So how about an example that involved the substitution type? Okay. So that would be the type 2 of this type of example. What's the question? That's going to be the one. Explain how I got the 104. Just common denominator here. See, the common denominator would be 4. So you have to multiply 26 by 4 because this is 26 over 1. 26 over 1. When you want to add the fractions, okay, you need to have the common denominator. So the denominator is 4. So we multiply the top and the bottom by 4. So the bottom one would be 4, which is here. And the top 4 times 26 is 104. You get that common denominator. Okay. So so let's have one with the case that we have to use the substitution method. This is the one. There is a technical point regarding this number, so be careful to see how we're going to operate. Okay, so that would be the type 2, and in this part is going to be example number 3. So what is this one? So you want to find this integral 0 to 1. Okay, to make it a substitution type is cube root of the 7x plus 1 dx. You see? Remember, if you want to find this integral, you have to rewrite it first. So that gives 7x to the 1/3, since it's a parenthesis to the 1/3. In order to find the integral, you have to use the substitution method. So we do the substitution method the same thing, but there is a technical parts that we're going to get into it. Okay, so the methods are going to be just the method that we did before. So let's rewrite it first. Okay, so this is going to be the solution. We have to rewrite it. So it's going to be integral 0 to 1, 0 to 1 what? 7x plus 1. 7x plus 1 to the what? 7x plus 1 to the 1/3 dx. So this means you have to use the substitution method. Let's see how we're going to get the substitution method for this this new integral. Okay, remember the substitution method. You take this one to be u. U is going to be 7x plus 1. So if you do the job, you must end up with the u to the 1/3. So that's going to be your u. Then you have to find the du. Okay, so what's going to be the du? The du, remember, we differentiate 7x plus 1, derivative would be 7 times the dx. Then we did find the dx. So the dx is equal to the du over 7. This is what we did before. We go and substitute, you end up with the u to the 1/3. Now, there is something else that you have to do in this part. What is that something else? You see this integral is from 0 to 1. 0 to 1 means x is 0 to 1. If you change it to the u, you don't have the x anymore. So you are going to have the u. So what you are going to do is you are going to find the corresponding numbers, okay, corresponding value of the u when x is equal to the 0 and when x is equal to 1. So you have two choices. One choice is ignore everything, just go substitute, get the u, and then get back to the x and use the 0, 1. But the other one is, which is easier. The other one is, since you're changing everything to the u, so how about these numbers? What is going to be the number for the u? So this is your extra job. Say, oh, if x is equal to the 0, then if I want to change it to the u, you see the u would be what? U is 7 times x plus 1, would be 7 times 0 plus 1. 7 times 0 would be 0, so that gives you 1. So when we change it to the integral, this integral will start from 0 to 1, but the other integral will start from 1. So how about when x is equal to 1? When x is equal to 1, so your u would be what? 7x plus 1, so that gives you 7 plus 1, which is equal to 8. So that's going to be your extra job. Because when you change the integral, you change everything. You change the x into the u, so you have to change the limit of your integration too. Okay, any question? So this is the one that probably you may miss when we get to the substitution method for these type of problems. Okay, so be careful. Now, yes, rewrite. This is it. What's going to be the integral now? So originally it was 0 to 1. 0 to 1, 7x plus 1 to a third dx. Now we're going to switch to the u. So it's going to be integral from, when x is 0, u is 1. So it's going to be integral from 1 to what? When x is 1, u is 8. So it's going to be integral from 1 to 8. 1 to 8 of what? 7x plus 1 is u to a third, times the dx as usual. The dx is what? Is going to be the du over 7. Okay, so since you're dealing with a definite integral, so you change everything. Even you change, you find the corresponding value for the u when x is equal to 0 and x is equal to 1. The rest is going to be just the usual substitution method. The leftover is going to be 1, 7. You pull it out as we did it before. It's going to be 1, 7 integral from 1 to 8. Okay, 1, 7 integral from 1 to 8 u to a third. Okay, du. Now we integrate u to a third. You move up the power. It's going to be u to the 1/3 plus 1 is 1 plus 3, which is the 4/3, divided by the 4/3. It's a definite integral. It's going to be evaluated from 1 to 8. No constancy. So we continue. 4/3, use the reciprocal, that give it 3/4. 3/4 of u to the 4/3, evaluated from 1 to 8. Now substitute. U equal to 8, so that give it 3/4 times 8 to the 4/3 minus 3/4 when u is equal to 1. Now it's going to be 1 to the 4/3. Okay, we just do the substitution as we did before. Now you have to take care of 8 to the 4/3 again, as we did for the other one. Okay, so what is going to be 8 to the 4/3? I write it down here for you. You see, 8 to the 4/3 is going to be 8 to the 1/3, then to the 4th. 8 to the 1/3 would be cube root of 8, which is 2. So that gives you 2 to the 4th. 2 to the 4th would be 16. So 8 to the 4/10 is equal to the 16. Okay, so this would be equal to, is going to be equal to 3/4 times 16 minus 1 to any power would be 1. So it's going to be minus 3/4. Okay, 16 times 3 would be 48. 48 minus 3 would be 45. So that gives me 45/4, the final answer. Okay, I want to finish it here, so I put it on the top here for you. Okay, so 16 times 3 would be 48. So it's going to be 48 divided by 4. I intentionally don't simplify it because I want to keep the common denominator. And this is going to be minus 3/4. Okay, minus 3/4. And now you just subtract. So that gives 45 over 4. So that's it. Integral from 0 to 1. A cube root of 7x plus 1 would be 45/4. And then you're done. You see, the case with the substitution, it takes a little bit more time to find it because of these technicality that you are going to have here. But it's not going to be, anything, any difficulty, if you like, to be able. We can handle it to get these numbers. Any question? So we do the substitution as we did it before, but since the situation is different, you have a range for the x, which is 0, 1. You cannot use 0, 1 over here. Some people, they made a mistake. When they go to the u, they write 0, 1. No, this is x, but this is u. So what you do is you have to do the substitution here. X equal to the 0. You see, you get x equal to the 0. When x is equal to the 0, the corresponding number for the u would be 1. When x is equal to the 1, you get the 8. So 0 to 1 would be changing to the 1 to 8 to get, to get through with these 3 numbers. Any question? So this is going to be type 1 for the substitution. I give another one. This one is again popular. Remember, we did have 4 types of substitution function. We have a radical function, okay, and we have the rational function. So let's see how we're going to handle kind of the radical rational function. For the rational one, this next one is going to be popular. So let's take number 4. You're just reviewing the method of integration that we did before, really, for this one. So how about this integral? We want to find the integral from 0 to 1. Okay, 0 to 1 of a rational function, 1 over 2x plus 1. Very popular case over dx. Okay, forget about 0, 1. You know that this is a rational function. On the denominator, there is no parentheses here. There is no power. We talk about it, you keep it as is. For the substitution method, you call this one u. You must end up with the 1 over u, which is ln u. If there was a parenthesis with the power, remember, you move it up, but not for this one. So this is how you do the substitution method for this solution. So you take the u to be 2x plus 1. Okay, that's going to be u. As usual, you have to find the du. So the du would be u prime. U prime is 2 times the dx. Then you find the dx. The dx is du over 2. Okay, so u is 2x plus 1. And the du is going to be 2 dx. Okay, we find the dx. But remember one extra job. The extra job is this one. X is between 0 and 1. So you have to find out what's going to be the case for the u. So when x is 0, you substitute to get a corresponding number for the u. U would be 2 times 0 plus 1. So that would be 0, that gives you 1. And when x is equal to 1, if you substitute your u would be what? Would be 2 plus 1, which is equal to 3. Okay, so your integral would be 0 to 1 when you're dealing with the x. When you change it to the u, would be from 1 to 3. Okay, so let's do it. This is the original one. 1 over 2x plus 1 dx. So we switch integral from when x is 0, u is 1. When x is 1, u is 3. 1 over 2x plus 1 is u. Substitute for the dx would be du over 2. Remember, you are looking for the 1 over u. So the extra term that you have over here is going to be 1/2. We pull out the 1/2. So it's going to be 1/2 integral from 1 to 3. 1 to 3, 1 over u du, as we predicted. Okay, we predicted for this type of problems. So what else? Now we integrate it. Integral of 1 over u would be ln u. So it's going to be half ln. We usually go with the absolute value of u, but everything is positive here. So, you can do the absolute value if you like. But you have to find it from 1 to 3. 1 to 3 means you replace u by 3. 3 is a positive number, so you don't need any absolute value. 1/2 of the ln 3 minus, you replace the u by 1. 1/2 of the ln of 1. You use your calculator to find the result. Ln of 1 is 0. So that would be 0. Ln of 3, you see, you use your calculator to get the ln of 3. So this is, remember, this is the ln of 3. That's going to be ln of 3. That is ln of 3. You need a 1/2 divided by 2. So that gives you 0.49. We may call it 0.55. Okay. So with the calculator, that's going to be 0.55. So the result is going to be 0.55. So the integral from 0 to 1, 1 over 2x plus 1 dx is equal to the 0.55, and then we are done. Okay, so in the case of the substitution method, the case with the ln function is popular, you see. So we just want to make sure that you are ready for it. Okay, any question? So this is a new integral, the definite integral. Okay, the definite integral, as you can see, the result is a number. The result is not a function. It's going to be a number, and it depends on the application that we're going to have. If in different places, that would mean different things to get these numbers. Okay, any question? And now I'm going to give a break now, because the interpretation of this integral is going to be two other quantity. Then we come back and then we give you those two quantities. One of them is the average value of a function. You see, previously you just find the average rate of change of the function. We can use the notion of the integral to find the average value. You see, if I give you 5 numbers, if I give you 5 numbers and I ask you what is the average of those 5 numbers, you add them together and you divide it by 5. That gives you the average value. But when you deal with the function, you see, if a function is given to you, you just drop the x in and you get the value of the function. So in the case of the function, you are going to have infinitely many numbers. You see, the function is this one, 1 over 2x plus 1. So if you check all the numbers between 0 and 1, you are infinitely many numbers between 0 and 1. So if you want to substitute, you get not 5 or 6 numbers. The number is going to be infinitely many. So if you want to find their average, you have to add all numbers together. It's impossible, you can't do it. But what we can do, we can estimate it by the notion of the integral. And that's quite interesting because in the application, you would like to find what's going to be the average cost, average revenue, okay? So if you want to do it, you can do it with the integral. We just got to know the formula, otherwise the rest is exactly the same thing that we did over here, okay? So that's part of this section. It's 8:15, we get something like 10 minutes. We come back, I just give you the definition. Again, the examples are going to be the same. So it's like practicing this one. Okay, so see you in 10 minutes. Okay, so a couple of application, and the one that let me just tell you what's going to be that those application that we're going to have for this type of integrals. So one famous one, as I told you, this is in section 5.4. Okay, it's a type of two types of applications. What's for the area problem, and the other one for the average value of the function. So we're going to take the average value of the function first. Okay, so what's going to be the average value of a function? Okay, that's one very famous application of this concept. As I talk about it, if if you have a finite number of the values, then you can easily find the. Okay, I'm just looking for that. You can easily find the average of those numbers. But when you're dealing with a function, the situation is going to be different. Okay, just bring some nice examples so we can check for you. Yes, that's it. So let's see what's going to be the idea of the average value of the function. So suppose a function is given to you, you see, suppose f is a continuous function, f is a continuous, okay, continuous function on a closed interval, okay, on the closed interval of a comma b. This is going to be the one. Okay, if this is going to be the function, you see the range of this function means the value of these functions or x between a and the b. So then the range, okay, the range of f is going to be what? Is going to be all numbers between, okay, between f of a and f of b. Okay, if you want to find all the numbers. So these numbers are going to be infinity many, not just 5, 6, etc. Note that. Just give you a motivation, then we can give you the formula right away. Note that there are infinity many. Okay, there are infinitely many. Just change this one. Okay, there are going to be infinitely there are infinitely many numbers. Infinitely many numbers between f of a and f of b. Okay, so the question is going to be how we're going to find the average value. So what is going to be? So the question is what is the average value of those functions, okay, of those numbers of f over, okay, over this interval. What we are going to do, we are going to change it to it's like the partitioning one that we did for the, okay, for the integral. It can be proved, but I'm not going to prove it for you. So I just give you this one as a theorem to get those average value. So this is going to be a theorem if f is a continuous function, if f is a continuous, okay, continuous function on the closed interval of A and B, then the average value, the average value of f over this interval A and B is going to be given by, this is the formula. So it's going to be average, is the way I'm going to write it down. Okay, average value of f, or the average, f average, sometimes we say average value of f is going to be 1 over b minus a times the integral of a to b f of x dx. It's a kind of the average because we divided by b minus a. It can be nicely proved, but we are not going to do it. Okay, so it's the formula is very similar to the integrations, and some people would be confused. But as you can see, you have 1 over b minus a, 1 over b minus a integral from a to b f of x dx. Integral from a to b f of x dx is just the usual definite integral. So a function and the closed interval would be given to you, you ask for the average value. You substitute and you get it. In your case, that function can be cost function, revenue function. So they may ask for the average, average value, average cost, average revenue. So they just put it in this formula and you get the result, okay? So it's nothing new. As soon as you get the formula, the rest are going to be the same thing that we did, okay? So we give one question on the next quiz and on the final. Any question? So this is how they're going to ask you, find directly, find the average value, find the average value of this function, f of x equal to the 6x squared minus 8x plus 1 on over on this interval of -1 and 3. That's going to be the question. The best example, unfortunately, we cannot give you those type of function. You see, when they talk about temperature, when you watch the news, they say, oh, tomorrow the temperature is going to be what? Tomorrow temperature is going to be between 46 and 82. So you may wonder how they evaluate this type of temperatures. So what they do during the year, they know what is going to be the distribution of a temperature in San Marcos area. That function would be a trigonometric function, something like sine of the pi 12x. So then they want to know what's going to be the temperature from 6 a.m. to 6 p.m. 6 a.m. to 6 p.m. would be 12 hours. So they use this formula for the interval from 0 to 12, and they find out what's going to be the average temperature tomorrow. You see, so it depends on the nature of this function, what this function representing, if you like, okay? And you will see, I give you a couple of them in your case. We have a nice one when we go to the review for the quiz. So this is it. Just make sure you know the formula. So in this formula, you see A is the smaller number, B is the bigger one. So in this case, A is a -3 and B is 3. So you write your formula and then you substitute and simplify it. Solution. So the average value for this problem, average value of f, the function, is going to be 1 over, okay, 1 over b and a. I write the formula again to explain it. Integral from a to b f of x dx. So in this problem, the smaller number a is equal to the -1, and the bigger number b is equal to 3. So form your integral. Okay, are you done? I have to go to the next page to explain it. So -1b3, so this is going to be the formula for this case. Okay, so we start with the average value. What's going to be the average of the f is going to be 1 over b minus a. B was 3 minus a is a -1. Make sure you use parentheses for the next part. It's 3 minus, okay, 3 minus -1. Integral from -1 to 3. Okay, f of x dx, your f of x is the function. The function is 6x squared minus 8x plus 1 and the dx. Okay, any question? So we have the a and the b. A is a -1, b is 3, and this is going to be the formula. 3 minus -1, negative would be positive, so this is 3 plus 1, which is going to be 1/4. Okay, so you just continue to find it. So it's going to be equal to the 1/4. Okay, integral from -1 to 3. The function 6x squared minus 8x plus 1 dx. It's just the powers of x, so no substitution, nothing is necessary or you need it. So you are going to integrate it. So you keep 1/4. Now you integrate. You see 6 is the number, 6 is the number. X squared, so that gives x to the 3rd over 3 minus 8. X move up the power, so that gives us x squared over 2 plus 1. The integral of 1 would be 1x x, but it's going to be evaluated from -1 to 3. You see, the operation is going to be just the integration that we did. Any question? Go on, simplify this one first. So it's going to be 1/4. And that give you 2. So that give you 2x cubed. 8 divided by 2 would be 4. So that give you minus 4x squared plus x to be evaluated from -1 to 3. So go on, substitute. So it's going to be equal to 1/4. So, you know, you can use bracket or just go ahead. Different way to go on. The way I do it is I put the bracket here and I replace the x by 3, then the -1. So that give me 2 times x3, 3 cubed, minus 4 times x squared, 3 squared. Okay, plus x, which is going to be plus 3, minus, open up the parentheses and do the -1. So it's going to be 2 times a -1 cubed, minus 4 times -1 squared. Okay, and minus 1. That is the second part. Okay, so just replace the x by 3, then x by -1. They'll go on. It's going to be 1/4. Simplifying 3 cubed. 3 cubed would be 27. Okay, and 27 times 2, so that you have 54. 3 squared would be 9. 4 times 9 would be 36. 36, and that's a positive 3. Positive 3. Okay, minus. Inside, a -1 to the third would be -1. -1 times 2 would be -2. Okay, then -1 squared. -1 squared would be +1. So that gives you a -4. And that would be -1. Okay, so we replace the x by 3. This is it. Okay, 3 cubed 27. 27 times 2, 54. 3 squared 9. 9 times 4, 36. And the 3. And this is going to be just a -1. What's the question? To get this number. Is it always? Yes, that's the definition of integral. Is you put x equal to 3, then minus the second part. That's the fundamental theorem of calculus that we talk about it. Okay, just continue to simplify it. So what else? It's going to be a quarter. So this is going to be the case. That's going to be 50. Okay, so that is 3 squared. That's going to be 50. 54 and 3 would be 57. Okay, that gives you 57. Just, simplify it in 2 steps. And inside is a -2, -4, -1. That gives me -7. There's a negative outside, so negative would be positive. Okay, so this is going to be a quarter. 7 and 57 would be 64 minus 36. It's going to be a quarter. And what is this? 28. Okay, 28 divided by 4, that gives me 7. So the average value of the function is equal to the 7. And then we're done. Okay. Again, as soon as you write the definition that you have, okay, definition of the average value, the rest are going to be, just the integrations that we did before. Okay, any question? So that's a kind of type 1 of the average value. There is a type 2. The type 2 is the one that you may have to use substitution method to take care of this function. For the substitution method one, in the examples that you are going to have, most of the time you are going to have exponential function. So for the exponential function, there is going to be a shortcut. So I give you that shortcut and I let you use it, okay? So let's give you a remark. You see, this would be very useful. You can use it anytime you like. You see, look at this integral. If you want to find the integral of a to the a times x dx, a is a number. 2x, 3x, 4x, 5x, only this one. Remember, when we differentiate it, when they differentiate this one, what was the derivative of e to the ax? Exponential function never change. That gives e to the ax. But remember, we multiply by u prime. U prime derivative of the top. Derivative of the top is a. So we multiply by a. Now, when you want to integrate it, it's going to be the other way around. You did multiply by a. For the integration, you divide it by a. Or otherwise, just a substitution method give you the result. So this result will be simply e to the ax divided by a plus the constant c. Since this is going to be used in the business problems quite a lot, we just make it as a formula and then we use it. Okay. Otherwise, you have to use substitution method. Okay, you take the u to be ax, you change it to the, okay, you change it into the u e to the u du, and you get, you arrive at the same result. But you can use it just for this one, okay? Nothing else. Any question? So, for example, you see, for example, if you want to find this integral of e to the 5x dx, you simply put e to the 5x divided by 5 plus c, and then you're done. And the reason is, that's it. If you differentiate it, it's a 5 times 5e to the, because the exponential function never change. It would be exponential function again, okay? But the u prime, in the case of differentiation, you multiply by 5. In the case of integration, you divide by 5, okay? Another one is the one that mostly we are going to use, going to be of this type. It's going to be something like negative point, okay, negative point, let's say 0, okay, 0.5x dx. The same thing is going to be equal to e to the negative 0.05x divided by the negative 0.05 plus c. Then we can simplify this one, of course, to get these numbers. Okay, any question? So we let you use it. We don't like it, you have to go through the substitution method. But this is how we're going to handle it, okay, in the case of the average value. It's very popular because the supply demands, okay, then the cost function, revenue function, all of them is going to be of this format. And this 0.0205 is just percent. It's just kind of 5%. So this is going to be used, very popular. Just check your book to show you one of them. And just give you something. We find it right away for you to get these numbers. Your book, the examples are going to be, you have a couple of them, but it is very, very easy. You have one in your practice one. Let me give you one. Okay, this is, no, your book is too easy. The one that it should be somewhere to get these numbers done. No, your book, they give you e to the x, which is going to be easy. But I give you a couple of application problems from everyday life, then you will see it. We don't want to skip anything. We want to give you example that would be useful for you to be able to handle good problem for us. Okay, so let's give you one. The book that we use at the university is much, much stronger than your book. And you get this type of examples from that book, and you will see it on your review. So let's give you the case with the average to see what I'm talking about. You see, look at this one. You want to find the average value of this function. Find the average. Okay, find the average value. Average value of this function. The function is f of x equal to f of x equal to the 100 e to the negative 0.02x over this interval, over the interval of, okay, the interval of something like 10 and 50. This is a typical problem that we're going to have. This is going to be, we call it the supply demand equation that denoted by S of X. Or sometimes this is going to be the, okay, the rate of sales, if you like. So when you see it in action of that format, if you like. But we just do the mathematics now. Okay, and so nothing new, average value. So you have your formula. You write your formula and you wanted to get it between 10 and 50, just substitute to get the result. Okay, so the official result is going to be, that's it. So we remind ourselves the formula again. You want to find the average value of this function. So it's going to be what is 1 over b minus a, integral from a to b. Okay, integral from a to b f of x dx. So your a is equal to 10, a smaller number, and your b is equal to the 50. So we substitute. So the average value is going to be equal to the 1 over b minus a is going to be 50 minus 10. Okay, integral from 10 to 50. F of x is 100 e to the negative 0.02x dx. 5 minus 10 would be 40. So it's a 1 minus over 40. Integral from 10 to 50. 10 to 50, 100 e to the negative 0.02x dx. 100 is a number, you can put it out. So that gives 100 over 50. Okay, 100 over 50, integral from 10 to 50, e to the negative 0.02x dx. Okay, then you can simplify it easily. Okay, to get the numbers. What's the question? Should the 1 over 50 be up in front? Oh yes, this is 40. Yes, this is what you mean. 50 minus 10 would be 40. Yes, thank you, Charles. Yes, that is 100 over. Okay, thank you. So it's 100 over 40. 50 was a nice number. That's why I like it. Okay, so this 100, that's 40. 50 minus 10, 40. So we can simplify it a little bit. What's going to be the result? We can simplify it by 20. That give you 5 half. Okay, it's going to be 5 half. 5 half, or you simplify it later from 10 to 50 e to the negative 0.02x dx. Now, for this integral, you use that shortcut that I talk about it. Remember the shortcut that I talk about it is going to be, so this is going to be 5 half. This is going to be e to the negative 0.02x, okay, over negative 0.02 to be evaluated from 10 to 50. 10 to 50. Any question? Now we do a little bit of simplification of these numbers. This negative would be the sign of the fraction. You have to multiply these together. So this is going to be equal to, you get the negative here because of this negative. This is going to be the 5. 2 times 2 would be 4. So that gives 0.04. And e to the negative 0.02x to be evaluated from 10 to 50. You can use your calculator. This would be what? This is 500 divided by 4. Okay, 500 divided by 4 would be, okay, 125. So it's going to be negative 125. Okay. And we have the e to the negative 0.0. You have to be patient to substitute these numbers. And eventually, of course, you have to use your calculator to get this number. So there you are. Is going to be negative 125 times it by. When you put the 50, it's going to be e to the negative 0.02 times 50 minus e to the, when you put the 10, negative 0.02 times 10. Okay, it's just a substitution. So it's going to be negative 125. You multiply these, what's going to be the result? E to the negative 2 times 50 would be 100. We have 2 decimal places, so that gives you just 1, negative 1. Okay, 2 times 50 would be 100. We have 2 decimal places, so you drop it. So that would be minus e to the, over here, 2 times 10 would be 20. We have 2 decimal places, it's going to be negative 0.2. Okay, but you know, you just use your calculator to get these numbers for the e function. So this is it. I need the e function, so I go with the second that will give me the e function. So e to the negative 1, e to the negative 1. Okay, that's it. Parentheses, close it. And that would be minus. I need the e function again. Okay, so that give me minus e to the negative 0.2. Negative 0.2, if you subtract it, that gives you the numbers 0.45. Then you multiply it, it's going to be negative 0.5. So you're going to multiply it by a negative 125. So that would be the final answer. Okay, 56.3 or 3.5. So that should give you 56.35. Okay, I just want you to try this one because this is going to be the type that you may have to, apply to get this, this result as an application problem. That's the best you can have for this group of the problems. Okay, so that is the average value and the application of that fundamental theorem of calculus that we are going to have. Okay, any question? So the problem in your book, just show you what is, they are all a kind of easy problem. Okay, this is what you have for the fundamental theorem of calculus. So if you, the substitution method, a couple of them are going to be a tricky one. This is like the one that I did. Is a little bit better. 1 over square root of 2x plus 1, 0 to 4. This is a very technical one for the substitution method. Okay, so let's try this one to explain this one too for you. Okay, the average value one are all easy. You see the function that you have for the average value. It's much easier than the one that I did. But let's try one of these. This is 2. So what I do, you have 31 and the 32. I do the 32, which is then you do the, the 31 yourself. You will see it on your practice one. This is a special problem. Okay, we give you the quiz. There is one more concept to talk about it. We talk about that one after your quiz. Okay, we want to have enough time to get practice. Okay, because they're all going to be given on the final. So this is this example from section 5.4. It's a very typical one. That and this is number 32. And make sure that you do the 31 to get these numbers. So what you want to do, you want to find this integral. Integral from 0 to 2, 0 to 2, and that would be x. Okay, that is x divided by 1 plus, okay, 2x squared dx. That's the best problem that you have, okay, from this section. Okay, it's 0 to 2, so that's definite integral. Okay, besides you have this radical, you know that you have to rewrite it. To rewrite it, we rewrite the bottom one is a 1 or 1 plus 2x squared to the half, and then we have to move it up. Okay, so this is going to be what you have. That's the point. The one that I did, the radical was up there and we didn't have any technical issue. Okay, so we have to check this one, 0 to 2, x times 1 plus 2x squared, everything to the negative half dx. Any question? So I changed the radical. I change it to the 1 plus 2x squared to the 1/2. But since it's done the denominator, I have to move it up at the same time. So when I move it up, the top would be negative 1/2. And we have to do it by substitution method because there is a parenthesis raised to something. So as usual, we take the inside parenthesis to be u and we are going to operate it, okay? So there you are. U would be 1 plus 2x squared. That is going to be the u. Then we go for the du. Du, differentiate. Derivative of 1 is 0, so that gives you 4x dx. Then we have to find the dx. So what's going to be the dx? Dx is equal to the du over 4x. Any question? But remember, there is something extra that you have to do. What is that extra thing? You see, this is a definite integral. And this is x from 0 to 2. When you substitute, you change the x into the u. So you cannot use the same number. You have to find the corresponding numbers for the u. So the extra job would be you replace the x by 0. You replace the x by 0. So your u here is going to be what? It's going to be u is going to be 1. It's going to be 1 plus 0, which is 1. And when you get x equal to 2, x equal to 2, we get the u. So what's going to be your u? It's going to be 1 plus 2 times 2 squared. Okay, 2 squared would be 4. 4 times 2 would be 8. So that gives you 1 plus 8, which is equal to 9. Okay, so this is integral from 0 to 2, and you change the x into the u. So what is going to be the result? So this is integral from 0 to 2. X times 1 plus 2x squared, okay, to the negative half dx. Now substitute. So it's going to be integral from 0 to 2. We change it. When x is 0, u is 1. So it's going to be 1. Okay, when x is equal to 2, okay, x is equal to the 2, then u is equal to the 9. So the integral would be from 1 to 9. We don't have anything to substitute for x, don't worry, it should be cancelled out. That's the x. 1 plus 2x squared is u, so that gives you u to the negative half. Okay, then the dx, your dx is going to be du over 4 times x. Okay, that's going to be the one. Any question? Now simplify the x and x would cancel out. So that gave you 4. So the leftover is a quarter. A quarter, you put it out. So it's going to be equal to a quarter integral from 1 to 9. Okay, 1 to 9, u to the negative half and the du. Now it's easy to integrate u to the negative half. We add 1 and we divide. So it's going to be equal to a quarter. Okay, that would be a quarter. And this is going to be u to the negative half plus 1. It's like negative 1 plus 2, which is going to be 1. So it's going to be 1 half. Okay, divided by 1 half. Remember, no constant c because you're dealing with 1 to 9. So it's going to be from 1 to 9. Any question? Okay, so we have to simplify it first, then substitute. It's divided by 1 half. You flip the 1 half. So that gives you a quarter. Okay, a quarter times what? Times 2 over 1. And then you have the u to the half from 1 to 9. Okay, so 2 and 4 would be simplified. That gives you 1 half. Okay, so that's going to be 1 half. That's a 1 half u to the half from 1 to 9. Okay, substitute. So it's going to be 1 half. So you can open up the parentheses and do the job. 9 half. So 9 to the half minus 1 to the half. That fundamental theorem of calculus that we talked about it. Okay, 9 to the half is radical 9 and the radical 9 is 3. So this is going to be equal to the half. Okay, that gives you 3 minus 1 to any power would be 1. Okay, so it's going to be 1 half. 3 minus 1 would be 2. So you simplify it, that gives you 1. So the result, integral from 0 to 2. 0 to 2 x, you don't have to rewrite it, but I rewrite it again. So it's a 1 plus 2x squared dx is equal to 1. Okay, so you got to be careful when we combine these substitution method with this new type of integrations. Those, those numbers, so you got to be careful to be able to, to take care of it nicely. Okay, so that's it. That's the most popular one that you are going to have. And again, I repeated that when you do the substitution method, you have to switch the limit of integration, we call it. You see, that's going to be limit of integration. That's for the x from 0 to 2. Okay, from 0 to 2 is the x. So when you change it to the u, make sure you switch the numbers to get, to get these numbers done. Okay, any question? So that would give us a nice idea of the application of this integral, this new one. We can start with the fact that this was the area under the curve. Remember, from that point of view, we can go to the area problem and do a little bit of this idea that we do it after your quiz. There are some properties, in your book, they talk about it now. I just listed. We are going to not use it quite a lot. It's nice to know to finish, this section altogether. We have a little bit time. So these are going to be used, in future, but not now. What is properties of this definite integral? Definite integral means the one that we talk about it. Okay, in application in future, you may have to use this type of ideas. One of them is this one. We talk about integral from a to b as an area under the curve. So what is integral from a to a? f of x dx. You see? Remember, this integral is the area under this curve. So you have a to a. In order to get a region, remember, you have to move. When it's a to a means you don't move. Okay? If you go from A to B, you just create a region. So A to A means you don't move. If you don't move, you're not going to get the area. So in this case, this would be equal to the 0. It would be useful, in some application to know it. So it doesn't matter, whatever function you have, integral from a to a f of x dx is equal to the 0 because the numbers are the same. So you're not going to create any region for us. Okay, this is one observation. The other observation is the direction that we go for this integral. You see, the direction is we have integral from a to b f of x dx. When you write this one, this bottom number must be smaller than the top. Sometimes you may be given the other way around. If you given you the other way around, you have to switch this, this integral. So what would happen if you switch it? Look at this one. The direction that you get for the area is from left to right. Integral from A to B would be the area. This direction is a positive direction. If you switch it, so you have to have the opposite sign. So integral from A to B f of x dx is going to be negative integral b to a f of x dx. Sometimes you may have to switch it. So if you change the direction, so you're going to have two different directions. So in that case, it's going to be negative of the other one. Okay, again, observation that would be useful. And the other one is, if you want to find this area, sometimes you may have to break it. Look at this one. If you want to find the area from A to B, you can divide it. You see, you can divide it in two parts. This is going to be C. So you can find the area between A and C. Then add it to the area from C and B. So integral from A to B f of x dx is integral from A to C f of x dx plus C to B f of x dx. Remember the piecewise defined function that we talked about at the beginning of the course? If this function is going to be piecewise defined function, and if you want to integrate it, you're just using this type of methods. So these are going to be used, for those purposes, if you like. But the one that you are going to use is the one that that I talk about. So these are from the point of view of the area, but the action one, the actual one, is the one that I talk about it. That's it. This is up to this section. 5.4. The average value, fundamental of calculus. There is only one other thing that we talk about. It's going to be area between two curves. I just talk about that one after your quiz, but otherwise we are done. Sometimes we move on to the next chapter, but it's not part of your your job, if you like. So I will post a practice quiz number 4 for you. Then I also post over the weekend. I will also post the final review. So when we come back, we can review for that quiz. We give you, because that quiz is going to be part of the final review too. Everything you do on the practice quiz will be repeated. Then we can review on Tuesday, give you a quiz on Thursday, and get to the final week of the course to get these numbers. Okay, so we are almost done with everything we need to know. So this would be your time to practice to get to get a good one on this quiz and on the final, and to get these numbers. Okay. Yes, I will post the problems for your assignment, which is going to be the last one. We just waited to see all the sections that we covered. So I post the practice quiz, your last take on one, you can get 2 more points. Okay, and everything. So we don't have anything else to cover unless other than prepare you for the final. Yes, I do that one too. Okay, any question? Yes, what's the question?
So we're not doing 6.1 and 6.4.
6.1, let's see. This is, I think, integration by parts. Sometimes we do that one and sometimes we don't. So 6 point, yeah, I know what you're talking about. This is the one that I do it sometimes when I teach it at what's the 6? Yeah, integration by parts. Yeah, we may touch 6.1 because you have 2 problems in your business that you need to that one. We do that one too. Yes, it's going to be integration by parts. I know what you're talking about. But yeah, sometimes I do that. Yeah, I do 6.1. Yes. Let's see how we can go with the quiz, because we have next week two sessions, one for the quiz. Yeah, we can do 6.1 too. But your assignment will be up to the whatever I did now. Okay, so let me post your final review. Then you will see that we are going to cover that one too. Yes, I do that. Okay, any question? So that's it. Have a good one. And just check that the reviews and the practice quiz that I'm going to post for you is going to be a nice one, because you need a method of substitution, a couple of application problems, and if we missed anything, you are going to see it on that practice one. And then for the final, you will see that mostly is going to be test 3 and quiz 4. You get only 2 questions from the first part of the course. When I post the final review, you will see it, and then we get enough time to review it. So you get a chance really to recover it, to pass this course, even if you get a 2 good grade on this one. Okay, and that would be the one. Yes, we got enough time to do the review. Yes, we do the review for you. Okay, have a good one and take care.